Hello, PreCalculus. We're going to talk about parent functions. This is really just a review. So tomorrow we're going to do a gallery walk where you've got different parent functions. You're going to have to know the name of them, maybe know stuff about their domains, ranges, and behavior, stuff like that. So everything that we've learned so far, you're going to have to be able to apply to this. So this will help us go back and practice some of the stuff like increasing and decreasing from section 1.4. And then I'll also have some rate of changes on the gallery walk tomorrow. So we can practice everything from 1.4 mixed in with knowing our parent functions. And then tomorrow night you'll be doing some transformations, and that's all that you'll have on your quiz on Friday. So the quiz should be increasing and decreasing, maximum and minimum values. Let's see what else. Maximum, minimum values, knowing all your parent functions, and then transformations. It should be a nice, easy quiz if you remember everything from Algebra 2. If not, you're going to struggle a little bit more. All right, so I borrowed these instructions because I want to not do it just for the scrub root. I want to do it for all of our functions. So this first one is called a constant function. It's really a linear function, but they do a special one for when you have a horizontal line. So remember, this is saying y is equal to c, some constant number. So this is y is equal to what? 1, 2, 3.5-ish. If I drew this line here, that'd be y is equal to 2. And so if we look at our constant function, the domain of this function, well, it's all real numbers. So this goes to negative infinity, out to positive infinity, no breaks in our domain. What is our range for this? Well, that's at what, 1, 2, 3.5 we said? So just the point 3.5 or the value 3.5. Do we have an x-intercept? No. So no x-intercepts. Do we have a y-intercept? You betcha, right? Wherever that c value is. So in this case, our y-intercept would be 0, 3.5. All right, is it continuous? Yes, we have no breaks, no jumps, no infinite discontinuity, so it's continuous on the entire domain. Or you could say continuous on negative infinity, positive infinity. What's our end behavior? This is good review from our last test. So the limit as x goes to negative infinity of f of x, where does it go to? It stays right there at that constant value. It's going to be 3.5. And our limit as x goes to positive infinity, what happens to your y's as x goes to positive infinity? They stay right there at 3.5. It is a constant function. All right. Does this graph increase or decrease? No. It's a constant function, so no increasing or decreasing. Intervals. It stays the same. All right, that's the constant function. Our next parent function would be our linear parent function. Sometimes you'll see this referred to as the identity function. And they call it the identity function because here's what it is. Or you might say y is equal to x, right? So if I plug in 1, what does it give me back? 1. If I plug in 2 for x, what do I get back? 2. So it gives me exactly back what I put in, and that's where they get the name identity function. So that's the special name for the parent linear function. What is our domain for linear functions? Negative infinity to positive infinity, all real numbers. What is our range? Again, goes down to negative infinity, up to positive infinity. It's also all real numbers. What is our x-intercept for the parent function? We just have this one intercept that's right there at 0, 0. What is our y-intercept? Same thing, right? 0, 0. Is it continuous? Yes. All of our polynomial functions, parent functions anyway, continuous on, this I'm going to write it the special way, continuous on negative infinity to infinity. So you can either say it's continuous on the entire domain, or you can say it's continuous on, insert the domain there. All right, let's start in behavior. The limit As x goes to negative infinity of f of x, as x goes to negative infinity, where do those y's go? They also go to negative infinity. What about when x goes to positive infinity? So when x goes to positive infinity, our y's go to positive infinity. All right, and for our parent function, are we increasing or decreasing or staying constant? Remember, you read your graphs, always left to right. So going left to right, this guy is always getting bigger. So it's increasing on the entire domain, which is negative infinity to infinity. All right, there's the linear function. Quadratic function. Someone tell me before you look at the graph, what kind of function is that? What does it look like? It's a parabola, Miss Harris. It's U-shaped. So our quadratic function would be f of x, in case you can't read that fuzziness there, is x squared. What's the domain of quadratic functions? All real numbers, right? This thing goes on and out forever, on and out forever. Doesn't matter, we can plug anything in for x and square it. So all real numbers. What about our range though? What's our lowest y value? Now we have a y value down here of 0, all the way up to positive infinity. Just like our linear parent function, my only x and y intercept is right there at 0, 0. So x intercept is 0, 0. Y intercept is 0, 0. Is it continuous? Yep, there's no jumps, no breaks, no asymptotes, so it's going to be continuous on the entire domain. So continuous on this domain would be negative infinity to infinity. Doing our end behavior, I've got the limit as x goes to negative infinity. As x goes to negative infinity, what's happening to our y values? They're going to positive infinity. What about our limit as x goes to positive infinity? We go to positive infinity, our y values are also going to positive infinity. All right, quadratics have an increasing portion and a decreasing portion. So let's write those both down. And then figure out what are our intervals. So where are we? Well, let's just go left to right and see what we come up with first. So going left to right, because that's the way we always read our graphs, I am going up or down? Down, right? So we go down to this point here, and then we start going back up. So the part where I'm decreasing is from negative infinity to 0. So remember these intervals always, oops, that's increasing, Sarah. Always, we're looking for the x values where my y values are decreasing. So the x values where my y values are decreasing. And remember, we never include that point where it's turning from increasing to decreasing. At 0, 0, we're neither increasing or decreasing, we're at a turning point. All right, so then our increasing would be from 0 to infinity. My y values are increasing. All right, and then for this graph, do we have a maximum? No, so no absolute maximum. But do we have a minimum? Yes. So we have an absolute this time with the absolute lowest point on this graph. And hopefully you're telling me it's right there where that vertex is, Ms. Harris. Absolute minimum would be 0, 0. All right, let's try to squeeze in one more. We're going to do the cubic function. Actually, I'm going to save the cubic function for the next one so that we have plenty of time to talk about the step function on a third video. So this is it for part 1. Come back and we're going to do some more on part 2.